Okay, everybody, we're ready to look at Lesson 3. Let's kind of reflect on what we've done. In Lesson 1, we talked about the three undefined terms of geometry, the point, the line, and the plane, and we know how to name those appropriately. We've talked about betweenness and congruence, and now we're going to talk a little bit about distance and midpoint. So here we're going to be remembering several of the things that we've learned in algebra before. We just want to be reminded of them. All right, talking about the distance on a number line. If we have a number line like we have listed here in example 1, we have the graph itself, we have the line itself, we have the dots graphed, and we have the coordinates here on this number line. The coordinates are going to always be the numbers associated with the points. So the coordinate for point C is -4. The coordinate of E is the point 2. Okay, so we've got to remember that the coordinates are the numbers associated with the points. Okay? Now, if I'm going to find the distance between 2 points on the number line, obviously there are times when we can simply count them. And there's nothing wrong with that, and there's nothing less mathematical or less honor student about that. That's perfectly fine. But we can't always count them. If I tell you to find the distance on the number line between 1.678 and 14 2/3, you can't just sit down and count those. So we have to have a method, a foolproof method that will work every time. So the distance formula to find distance on a number line, we take the absolute value of the difference of the coordinates. The absolute value of the difference of the coordinates. So let me write that down. For distance, D for distance, and I'm going to put a subscript. Distance subnumber line. We take the absolute value of the difference of their coordinates. Now we put the absolute value there because by doing so, we don't have to worry about if we have put the largest coordinate in or not. If you always put the rightmost coordinate in regard to the number line in, you really don't have to worry about the absolute value. But you don't know that you're always going to be doing that. So you're going to always want to take your absolute value of your distance of your coordinates. So if I want to find the distance for AC, I could count it, 1, 2, 3, or I can say the absolute value of -7 minus -4. Now notice that the minus is a part of the formula itself. It doesn't replace this negative sign. Okay, the minus has to be in the formula. So -7 minus -4 is the same thing as adding the opposite, right? So we've really got the absolute value of -7 plus 4, which is -3. So just like we counted, our distance is 3. Again, the absolute value of the difference of the coordinates, when the coordinates are the numbers associated with the points, that is how we find the distance on a number line. Now remember, on a Cartesian plane, or the coordinate plane, or the XY graph, many ways that you've probably heard that referred to. This time when you find the difference, or the distance, you've got an X and a Y, you're having to deal with two different things. And by looking at a proof or a derivation of the formula here, by using the Pythagorean theorem, we can see where the distance formula comes from when we're finding the distance on a coordinate plane. So if you are given any 2 points, we're going to use ones they've given us here below. if you're given any 2 points on the coordinate plane or the Cartesian system, to find the distance between those 2 points, we're going to take the square root of the difference of the x's plus, now since I put this x first, I've got to put this y first here, okay? So I'm going to have negative 5 minus 8 squared plus 6 minus negative 4 squared to find the distance between those 2 points on the number line. Again, if you have a horizontal or vertical line, you can sometimes count, but that's not going to always be our case. And with the Cartesian plane, it seldom is going to be the case where we can count it. So we're going to have to be very familiar with this formula and have it memorized. I think I mentioned that as one of the things in lesson 1 that I expect you to know and carry into geometry with you. So let's do this arithmetic now. Negative 5 minus 8 is negative 13. And then 6 minus negative 4 is going to be 10. Okay, and then we're going to start simplifying further. Negative 13 squared is 169. And 10 squared is 100. So we need to take the square root of 269. If that is a perfect square, in other words, if it comes out even, we're going to go ahead and take that perfect square. If this doesn't come out even, the most accurate answer is to go ahead and leave this in simplest radical form instead of putting it into your calculator and rounding it off. So anytime that your book asks for the exact measure, they mean they want the answer left under the radical sign so that you haven't rounded off anything. Or if you're using the irrational number pi, they don't want you to put in 3.14 if they ask for exact number. They want you to carry the pi along with you and have that in the answer. Okay, so this should be a review for you of the distance formula on the Cartesian plane. So right now we have two formulas that we've talked about. The distance on the number line, absolute value of the difference of the coordinates, and the distance on the graph board, the square root of the difference of the x's squared plus the difference of the y squared. When I was in Algebra 1, my teacher gave us a silly way to remember that formula, or at least where the signs in that formula go, because it's easy to mix up if you should have a plus in the parentheses and the minus between the two parentheses. So he always told us to think of the plus as like being the nose and the minuses as being the eyebrows of a person. So that may help you remember and keep straight where the pluses and minuses are supposed to go. All right, now we want to find the way that we're going to, or we want to talk about the way we're going to find the midpoint of a segment on the number line and the midpoint of a segment on the Cartesian plane. And they're both very, very, very similar. When you find something in the middle, when I find the middle of your grade in the fall, I'm finding the average, the closest number to the middle of all the numbers that I've been given. And that's exactly what you're going to do when you find the midpoint on a number line. You're going to take the average of the two coordinates. Okay, the average of the two coordinates of the endpoints. So if I have a number line and I have the segment that's extending from -2 to 7, and I want to know the midpoint, then I'm going to just add my two coordinates together and divide by 2. So halfway between here would be 2.5. Okay? Now the averaging concept carries over onto the coordinate plane as well. If we want to know the coordinate of a point that's between two other points. To find the coordinate of the x, which is called the abscissa, or the x-coordinate, then we just average together the two x's of the endpoints. And if I want to find the y-coordinate, I just average together the two y's. And the y-coordinate's called the ordinate, by the way. Okay? So if I'm finding midpoints, I'm thinking averaging. So if I look at this particular example that they've given me, actually I'm looking at 4A down here. If I want to find the midpoint halfway between A and B, then I'm going to look at the two x values, which are 5 and -4, and I will average those. And then to find the y piece, the ordinate of the midpoint, I take the 12 and the 8 and average those. Then as I work this out, I'm going to find 5 plus -4 is 1, so 1/2, and then I've got 20 over 2. So 1/2, 10 would be the midpoint on the Cartesian plane of those 2 points. You're given another example here that you can study if you need that. But again, this is review for you. Now, what we want to look for now, or what we want to make sure we know how to do, is find a missing endpoint. Okay, you can find the midpoint pretty easy, but let's find the missing endpoint, and we're going to find, dears, that it's not that much more complicated. All right, so let's pick an example out here. I'm going to make my page a little smaller. Okay, let's say that we are given, and I'm looking here at the guided practice right in here. Let's say that we're supposed to find the coordinate of an endpoint if P is the midpoint of EG. Okay, so we've got some segment EG, and we are told that P is the midpoint, and we're told that E on the Cartesian plane is at -8, 6, and that P is at -5, 10. This time we're looking for the other endpoint. Okay, so we're looking for this guy out here, the ordered pair that goes with this guy. All right, we're going to use the same concept. See, we've got to find an ordered pair here. Let's use the exact same concept that we used above. If I take the average of the x's that are the endpoints, that should equal to the x of the midpoint. And if I solve for x, then I'll know what my x is on over here at G. So let's multiply each side by 2. And let's add 10. So the x for my other endpoint is -2. Now we're going to use that same concept to find y. Our y for our E is 6. We don't know the y for the G, but we know if we average them together, we're going to get 10. Multiply each side by 2. Y is 14. So -2, 14 is the other endpoint when I know that E is one endpoint and P is in the middle. Now, that is not very difficult at this point, but I want to do one more with you just like that, because in years past I have done this problem, and you can always rewind and pause if you need to study that more. I've always, kids have told me that's easy in class, and then the next day at school they wish that we had seen more examples. So let me do another example of that one, that when you are given one endpoint and the midpoint, and you have to find the other endpoint. Okay, so here's EG again, and P is in the middle, and we've got to find this ordered pair right here. So we're going to take the 5, that's the x for the G, and add that to the x that we're looking for. Divide it by 2 because we're averaging, and that will give us the -1. That is the x of the midpoint. We'll multiply each side by 2 and subtract 5 from each side. X is -7. Now let's find the y for the other endpoint. The y that we know is 6. We're going to add that to the y we're looking for and divide by 2 because we're averaging. And the averaging gives us 3. Multiply each side by 2. Y equals 0. Don't get uncomfortable when you get a 0 on one side. 0 is a perfectly good number. Okay, so -7, 0 on the Cartesian plane would be the other endpoint on this particular segment, and you could graph it to show yourself that it's true. All right, we've got just a couple other things here we want to look at. On this page, find the measure of PQ if Q is the midpoint of PR. So this time we're seeing that not only do we have betweenness, we have a Q that's between PR, they're collinear, and Q is between PR, but this time they're telling us Q is a midpoint. So if it's right in the middle, that means that PQ is the same length as RQ, or they're congruent, they're equal, they're the same shape and size. So that means that my 9y minus 2 is the same measure as the 14 plus 5y. And you can see how they work it out. So make sure you're careful with our vocabulary. When you have a midpoint, you are empowered to set sides equal to each other. Let's look at an example 6a. Find the measure of YZ. Now I'm going to have to draw this. By now you're learning I am a visual. So we've got YZ. If Y is the midpoint, okay, now do you notice what I've done? I haven't given myself enough room. So I should have read the whole thing first. I'm glad I made that mistake because I want you to see that it's okay to make those mistakes. So this time I'm going to make my line a little bit longer, my segment a little bit longer, and we're to find the measure of segment YZ if Y is the midpoint of XZ. And again, we've learned that Y is in the middle. Remember that the little hashes means that those two segments are going to be the same. Now let's put the information on here. XY is 2x minus 3. And YZ is 27 minus 4x. So since Y is in the middle, I can set these two algebraic expressions equal to each other. Okay, I'm going to add 4x. And then I'm going to add 3. And it looks like x is 5. And let's make sure we're answering the question. Find the measure of YZ. So YZ is the 27 minus 4x. I could really plug into either one since I'm looking for congruence here. But 27 minus 4 times 5, which is 27 minus 20, or 7. Now I can check that to see if I feel good about it, because I could put 5 into this one and make sure I get 7 as well, because those two have to equal. And then when I do see that they're both 7, I feel pretty confident that I've got them right. Okay? Let's look at 6b. And you can pause if you need to get any of these notes down. But I want to look at 6b here. All right. Find the value of x if C is the midpoint of AB. There's my midpoint, okay. AC is 4x plus 5. AB, that's the whole thing now, is 78. And we've got to find x. Now remember, kiddos, that x is in the middle. So if AC is 4x plus 5, then CB is another 4x plus 5. So I can look at this one of two ways. I can say, okay, if I have two 4x plus 5s, that gives me 78. Or if I just have one 4x plus 5, that's half of the 78. So that's going to be about 39. So I can go about this either way. Neither one is more honors student than the other. They're both just perfectly fine. So if I solve this out, let's just go ahead and solve it so we know we get an answer here. 4x equals 30, excuse me, 34. And x is going to be 17 over 2. And we're not going to be upset because it didn't come out even. It can be perfectly happy that it came out to a fraction. So don't get upset about that. Now, the next thing I want to look at down here is this this term, segment bisector. This is really important. Any segment, line, or plane that intersects a segment at its midpoint is a segment bisector. Okay, so for it to be a bisector, a line, a segment, a plane, a point has to be right in the middle of that which it is bisecting. So in the figure at the right here, this figure, we are told, or we are shown, that M is in the middle of PQ, and again, it's because of those little hash marks showing me that from M to P, it's the same distance as from M to Q. So having those little marks empowers me to know that M is in the middle. So point M is a bisector of the segment. But also line KM is a bisector of the segment because it's going through the segment at its midpoint. Segment JM is a bisector because it's going through at the midpoint. And then plane A is also going through segment PQ at its midpoint. So anytime that a segment is intersected at its midpoint by another segment, a line, a plane, or point, then we have a segment bisector. And when we have a segment bisector, we know that the two parts of the segment have to be equal to each other. All right, I want to show you something at the top of the page here. This is called a construction, which you're not going to do by yourself over the summer. This is called a construction. Back in the Greek days and the Roman days when early mathematicians and philosophers were developing these ideas and pulling things together, they didn't have all the tools, obviously, that we do now. So they would use simply a compass and a straight edge to draw perfectly proportioned and beautiful drawings. And they had certain techniques that they could use to always know that certain things were always equal or in thirds, or it was just a method that they used. Now, we may work in some constructions in the fall, but we may not. My main purpose of mentioning construction is just basically for you to know what they are, and I hope we'll have time to do some when school starts. It's not a priority for me because we have so many other things to cover, but I think you would enjoy it if we could at least take one day and do some constructions in class together. I think you really would like it. All right, we find ourselves at the exercises, and I want to make sure that we are set to do what we're called upon to do in the worksheet that I've given you. Use the number line to find each measure. Remember, we're going to take the absolute value of the difference of the coordinates. So for x, y, x is at -1, and I will subtract from that 7. So I get the absolute value of -8, which is 8. And if you count those, I'm sure you're going to see the same. If we have to find the distance between 2 points on the Cartesian plane, we're going to use the difference of the x's squared Difference of the y's squared. Remember the nose and the eyebrows that I mentioned and how to remember. Finding the coordinate of a midpoint. Remember again, midpoint, you take your two coordinates. That's the two numbers associated with the points and divide by 2. And that's your midpoint on your number line. Midpoint on the graph, we average our x's together to get the new x. We average the y's together to get the new y's. I hope, and of course there's no way for me to know this as I'm making the video, but I hope that you are giving me feedback and asking questions along the way and feeling free to make comments and questions in the Google Classroom if there is something you're not comfortable with or comfortable about. Let's look at number 12 together. This is a good problem, and this is the kind of problem that I could see myself giving on a test. Oops. There we go. So we've got point M as the midpoint. We have to find the value of A. All right, not too bad. Remember that, let me get my black pen back. There he is. Okay. Remember that the midpoint is the average. So I'm going to take the x of the C, which is A, add that to the x of the D, average those together, and that's going to give me 6. Multiply both sides by 2 and subtract 9. A is 3. Okay, so we should be fine there, but we can double check that. If A is 3, then 2A is 6. Let's see if 6 plus 2 when averaged together gives me the 4. 8 over 2 is 4? Yes. So that's just sort of a check that's built in. Okay? Don't let the fact that a problem looks a little bit different scare you away. Those are the problems that I love. All right, let's move on. I think we're good here. Finding the missing endpoint. Let's, I think we've got that pretty well here. Find the coordinate of the missing endpoint B. If B is the midpoint. So we've got AC again, and we're finding a midpoint. I did a couple of those earlier, so I think that you're in good shape there. If you're not, though, you know to contact me. But I like these down here. Let's see what we've got on 64 and 65. They look a little bit more interesting than some of these others. Okay. We're on the coordinate plane. Let's see what happens. I'm sorry, that goes with another one. Let's look at what we've got. We've got JK where we are on the coordinate plane because we've got X and Y's. So looking at number 64 here, let's play with that a little bit. Determine the value of N. We have J and K, and we know JK is 5. Now, there's no symbol, so that means that we know the distance from J to K is 5. So let's use the distance formula. All right. I'm going to start with the 3N, so X minus X squared plus. Now, dolls, since I started with the 3N, over here, I have to start with the N minus 1. N plus 2 squared, and that equals 5. This will be fun. Okay, here we go. 3N minus N is 2N squared. Now, in here, I've got to remember to distribute that negative. Cleaning up pretty good now. Remember, the 2 gets raised to the power of 2 as well as the N. Okay, looks like my N's are going to fall out. And that's going to leave me negative 3 to square. So we've got 4N squared plus 9 equals 5. Now remember, when I've got a whole radical on one side, what I like to do is square both sides of my equation. So when I square both sides, that's going to lift my radical. Subtract my 9. Let's divide each side by 4. I'm going to come over here. And then I'm going to take the square root of each side. Now I've got to look and see if plus or minus 2 will fit with both of them, or if I just need to get my plus 2 either way. Let's see here. What I would want you to do is put in check your plus and your minus 2 and see if we get a true statement when we find those that distance in there. Okay? I'm going to predict that the negative 2 is not going to work, but we would need to check that. I'm just going to make that prediction right now for our purposes. Okay? Now again, kiddos, these are the types of problems I love to give on a test. So this class is not just to learn the skill and I'll test you and you spit back out just the skill part. You've got to be able to analyze and apply. That's the most important part of geometry. The analysis, the logical reasoning, developing those skills is the most important thing you can carry with you out of geometry. Okay, so we'll be looking at problems like this throughout the year. Don't shy away from them. Okay, alrighty, that's going to close us down for section 3, and we will open back up with the video for the last 3 sections of this chapter that we're going to do before school starts. If you have any questions or any comments, anything you're concerned about, we want to hammer those problems out now. Don't hesitate to leave me a comment or send me an email with a question so I can help you be prepared with a good solid foundation, and we can start working on reasoning the minute school starts. See you later.